So, welcome back to the show. In this video, you will be seeing how to solve another problem by using KVL. In the first video, you have seen how to solve a problem, introduction of KVL, and I have solved the problem by using KVL also in a simple manner, but it's a bit difficult and it is a complicated problem. Okay, and in this problem, he has asked determine the voltage P in the circuit. He has asked determine the voltage V in the circuit. So, in this is a circuit where you have one voltage source. 8 volt is a voltage source, 8 volts. A current source given with an arrow, so this is a current source 6 amps. We have 4 resistors and I have 3 loops. So 1, 2, 3 loops, closed loops. Okay, so he asked to find out the voltage. Where is the voltage? This is the voltage. He asked to find this voltage. Okay, so let us write the equation, and in that equation this V also will be considered. Okay, and let us do. Okay, so 3 loops I will be taking as I1, I2 and I3. Okay, let me take the first loop, this loop. So as your current flows from plus to minus, right? So plus to minus. So here this is the direction. Here current flows from plus to minus, so this is the direction. I'll follow the same assumption of the direction all the other loops. This loop I1 which I have taken plus to minus, so I have taken plus to minus. So this is the loop direction. I am taking the same loop direction all the other loops, same loop. Okay, even in this case, same direction, same direction. In order, this is I3. Okay, I am telling you again. I have taken I1 this loop only into consideration. Okay, only in this close, only into consideration. And plus to minus is always which I take the current assumption positive to negative. So current is flowing from positive to negative. So in this way. So I have taken the same direction of the loop in all the other loops also, I2 and I3, because to avoid like confusion. Okay, now let us start writing. Okay, let me write all these three here only. Okay, now for loop 1, this loop 1, okay, where I have taken I1. Right. Now let us take. So obviously the current is coming like this, right? Current is coming like this. Okay, and the current is coming like this. So it entered plus and leaving. Sorry, entered this minus and leaving this plus. So here we take only the leaving sign. So here it is plus. So plus is a voltage source. Directly we write 8 because V is equal to IR. Every time we need to write V is equal to IR. This is directly V. Okay, and here if it enters here, always the current when enters the resistor it is plus. Okay, when it is leaving, it becomes minus, because the resistance has a property to oppose the current, because when current enters here, when it is leaving, obviously some of the current is lost. That is the reason we are taking minus. So we will be taking only the leaving sign, so it becomes minus. Okay, here we have to write V is equal to IR. To find the voltage here, we need to write V is equal to I into R. What is I? I is I1. What is R? R is 4. Okay, 4 into, here current is, I1 is flowing here and I3 is also flowing here. Now let us see what is the flow. In 4 ohms, your I1 is flowing in this direction. Okay, your I3 is coming in the opposite direction. This I3, this I1. Okay, so I1 minus I3. This total becomes a voltage. Okay, at 4 ohms. Next, the current is coming here. It entered 3 ohms, so it is plus, and when it is leaving, it becomes minus, so it becomes minus. Here it is V is equal to I into R. I is I1, R is 3, so 3 I1. We don't have any other current which is passing here. and that is equal to 0. Okay, so I'll tell you again. I'll start from here. Current is like flowing in this way, so it entered with a minus and left plus. So the leaving sign is taken plus into the direct voltage source. Okay, when it entered the resistor, it is plus. When it is leaving, it is minus. So we'll take only the leaving sign, that is minus. 4 is the resistance. And what is the current which is flowing in the 4? We have I1 and I3 because it is in between I1 and I3. See the directions. I1 is coming downward. It's coming from the downward, is going up. And I3 is coming from the, see, it is the opposite direction. It's like coming like this and it's coming like this. So, I1 minus I3, okay, minus, when it comes here, it leaves here, minus 3 I1. Okay, and if you, like, how you have written directly, so you see my previous video which I have given you the link. Okay, you see my previous video and there you can find how to write individually. Okay, I'm writing directly. So, this is, let us solve here. 8 minus 4 I1. I'm sending the 8 to the other side, becomes minus 8. Okay, I'm cancelling everything with minus, so this becomes so 7 minus 4 8 is my first equation for loop 1. Okay, now let me take for loop 2. Okay, okay, I'll draw a diagram to avoid confusion. For loop 2, so this is the voltage source. This is 5 ohms. And this is the current direction is like this. And this I2. So I2 is coming like this, and 5 is in between I2 and I3. And I3 is coming from. So this is only for loop 2. Only this one. Let me write directly. Okay. So this is how I have taken current direction. So current is coming like this. Okay. From here I'll start. Current entered this plus. See, only for here. Okay. This is much confusion. Definitely. Okay. See, current is coming like this. It entered plus and left minus. So it becomes minus. The leading sign will take 8. Voltage directly is 8. Okay. And it came here. It obviously plus when entered resistance, and when left it becomes minus. This is 3. So here voltage is V is equal to I into R. What is I? I2. R is 3. So 3 I2. There is no other current which is flowing in this 3 ohms. Okay. Then current is started like this and we are going like this and entered here, then become minus. The left is always you can take it when current is leaving the resistance, take it as minus. Okay. Minus, your resistance is 5. But how currents are there? See here. There are two currents which I2 is what we have taken, current is entering from down, and I3 current entering from top. These two polarize each other. So it is a division. So I2 minus I3. As I am taking I2 loop, so I put I2 is priority, and that is equal to 0. Okay. So solve this. When you solve it, you have to be very, very careful with the one sign you are lost. So this becomes minus. Do along with me when you are doing the problem here, because like you will get to know. It's equal to 8. Okay, I don't want a minus here, so I'll divide entire thing with minus. So this becomes plus and this becomes minus. So that's second row which I know. Okay, now let me go to the third one. And divide the page and then get the to the side, and let me draw loop 3 which are taken I3. So for loop 3, 4 is there, 5 is 4 ohms, it's 5 ohms. And there is one current for 6 amps, and you're fast to find the voltage also here. Okay, and the direction is, so I3 is down. Okay, so I3 is also coming down. But for 4 ohms, there is one current which is coming, this I1. So I1 is coming from bottom. So this is I1. Because 4 is in between I1 and I3, I1 is coming from bottom. Okay, and here for 5 ohms in between I2 and I3, and I2 is coming from bottom. Okay, so to make it more clear, this is like 1 side. Okay, now let us write the equation. Okay, so as we're writing all the currents, right? The current here is equal to total current. We are writing the voltage source here. The voltage source at here and here. Okay, and here we have a current source. So indirectly, if we have given a current source as 6 ohms, okay, we'll keep it this aside. I'll tell you because he has given directly 6 amps is given, but here is given the voltage. So the voltage at here, the voltage here is equal to total voltage. Okay, or we can take the entire thing at once. See now. So it is coming like this. So indirectly it is plus and minus. Here the voltage is plus and minus. Okay. So when I3 is coming in this way, so I'll start from here. It started minus and the left side is plus. It's leaving voltage at plus. So I'll write plus V. Okay, I'll write plus V here because I'm writing all the voltage. The algebraic sum of all the voltage is equal to 0. So plus V. It entered here. Obviously, when it is entering, it is always plus. When it is leaving the resistance, it becomes minus. So I'll write minus here directly, and I into R. That voltage here is V is equal to I into R. So I'll write R first 4. And what is I? There are two currents which are flowing here. I1 is coming from the down, I2 is coming from the top. Okay, so it is a difference. As we are writing loop 3 I3 into consideration, so I'll make prioritize I3 minus I1. Okay, of this load. When it entered plus 5 ohms, it's become plus, and when it is leaving, it becomes minus 100. So minus, resistance is 5. And what are the currents which are flowing into 5 ohms? I2 is coming from the bottom, I3 is coming from the top. See, there are two currents. But 5 ohms is in between I2 and I3. So I3 minus I2. Because we are writing loop 3, so I3 is equal to 0. Let's solve this thing. See the video without skipping so that you don't leave anything here. So I'll rearrange. I'll write I1 first, write I2 minus. So minus 4 minus 5 become minus 9. I3 so this becomes your loop 3. So now I have 3 loops. I'll take this one now. See, I have 3 loops. 1, 2, 3. I got 3 equations. Okay, instead of solving all the 3 equations, what I do is, see here in this third loop, it has given us 6 amps as the current source. So indirectly we are seeing that 6 amps is the current which is flowing here. As we have taken I3, so indirectly he has given like I3. What is the current which is flowing in third loop is I3, and that is equal to 6. So that is the meaning of that. Okay. Now what I'll do is I'll simply put I3 is equal to 6 amps in 1 and 2. We'll keep in 1 and 2. So the first equation 1, 7I1 minus 4I2 is equal to 8. Because it's simple, so I started with this. Okay, so I'll substitute I3 here. So minus 4 into 6 is equal to 8. So obviously 7I1 minus 6 4 is 24 is equal to 8. If you solve, you get I1 as 32 by 7, that is nothing but 4.571. So I1 is equal to 4.571. Directly I got the I1. Okay. So let us take the second equation. In second equation, Equation 2 is 8I2 minus 5I3 is equal to minus 8. I'll keep I3 is equal to 6, which is given here. 5 into 6 is equal to minus 8. So 8I2 minus 6 by 30, right? So minus 8. So 8I2 it becomes minus 30, becomes when it goes there it becomes plus 30. So the answer is 22. I2 is equal to 22 by 8 and I2 is equal to 2.75. I got I1, I got I2. Now to find out I2 is very, very simple. Go to equation 3 directly. What is equation 3? V plus 4I1 plus 5I2 minus 9I3 is equal to 0. I have I1, I have I2, I have I3. Substitute directly without any back looking. Don't see anything in any other direction. Directly substitute I3 is 6. If I solve, let me solve 4 into 4.57 is 18.8 plus 13.75 minus 9 6 is 54. We get to the tables also. So if I solve this becomes minus 21.9. So V minus 21.9. Now I'll send this minus 21 to the other side. So this is V is equal to 21.9. Directly I got an answer. V is equal to 21.97. See how simple it is. Okay, even though we got a complex problem, we are doing it very simple. Now let me write the answers. Here V is equal to 21.97 volts. Okay, and I3 is equal to 6 amps, which we have given. I1 is equal to what we got here? 4.571 amps. I2 is equal to 2.75 amps. So this is how you have to solve the problems. Okay, and you have to find the currents and the voltage also. Even though it is a big complex problem also, make sure you take one loop, you assume one direction correctly, okay, and make the direction similar to all of the loops. Don't look into the voltage in all the loops, just make the assumption same in all other loops so that you get your answer very easily. Okay, thank you.